Another in a series of videos, basically asking the question, why can't this alternative explanation, why isn't it just as valid or more valid, frankly, than the conventional held beliefs, 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 they are mistakes, of conventional physics. So the subject is generally this idea that gravity is bent. Gravity's bent. Sorry. Tired. Yeah, it's early in the morning, but I'm tired. Anyway, that light is bent by gravity. So first, quick history of Einstein came up with this notion that somehow all motion is equivalent or something. All velocities, all accelerations are exactly the same. Elevators in space are the same as gravity on Earth. If you're getting pushed directly by a force, is the same as getting pushed by something banging into you and forcing you. But whatever. Yes, the end consequence of having velocity, I would argue that probably is equivalent, but the way you gain velocity isn't equivalent. But regardless, so to defend this idea of this equivalency, he came upon the problem of the light clock, which seems like a universal clock, a clock that you can't break. It's too elemental. So it's the most elemental clock we know of. And the idea is you just bounce a photon from a surface to a surface and receive it, and by measuring the distance you accurately know how much time has passed. The most accurate way you can know. And you also can see path changes, in the sense that if you move your emitter or you move your receiver to a different location, that'll have a consequence on the photons, in the sense that the photons will not acquire, they have no knowledge of their history and no knowledge of their destiny, in the sense that they just travel in a straight line. So the idea would be, as the elevator walls are moving, if you're falling in an elevator, and the perception, the idea would be a rocket ship, the walls would be moving, and if you shot light across, the light would hit lower on the rocket ship wall than your expectation, as you don't know you have velocity. And so he had to duplicate that, and he had to make the same thing happen on Earth when you're moving in gravity. So he had to make essentially light bend down, so it would hit the proper spot on the wall, quote unquote, if we were in acceleration that was as fast as half the speed of light or something with the theoretical rocket ship. So if you were in heavy, really strong gravity, the light clock would do the same thing in on a black hole. If you could stand on the black hole, the light would do the same thing as it does in the spaceship, which is it wouldn't travel a straight line across perpendicularly, it would fall. So he had to make the two the same, and to do that he had to double the effect of gravity on photons. That is, by velocity, he increased the effect just on the single atomic particle, is twice as affected by gravity as everything else, because it's really a speed thing. It really doesn't have anything to do with your mass. How you're affected by gravity is sort of mass independent, because it's always be proportional to your mass. So it'll apply as much gravity as necessary, dependent on your mass. So mass becomes irrelevant in an equation, and the only thing that really matters is your velocity. So velocity decides how much you get bent. And he had to make photons bend twice as much as every other piece of matter in the universe, and mostly just electrons and protons, because they're really the only other pieces of stuff. There's force bits, and then there's the matter bits. And well, anyway, so he's basically saying the force bits are bent in gravity. Now the first proof is the famous Eddington experiment, which is just terrible science, in the sense that it's marginal. Even if under perfect conditions, it was clearly done under incredibly imperfect conditions. It's they approximate it to be something like measuring a human hair's worth of difference in an object at, say, 30 feet, which is a pretty delicate measurement. And again, done under really lousy conditions, 10% of what they were, of their expectations. But yes, hailed as proof Einstein is correct, because they found enough deflection in time-lapse photographs taken over, I think, a 7-minute period of time. So just blurry smudges on a film, and they found enough, and there's obvious and, I think, reasonable reason to be skeptical of the quality of that experiment. Yet the promoters are just so aggressive in saying they've proved something when they haven't. So the famous New York Times headline, Einstein correct. All of a sudden, relativity is a true theory just because they found one correlation. All right, so then later, time elapses, and then they get these pictures from space, and they see these phenomena. And let's just point out the Eddington experiment never successfully repeated from an Earth-based telescope with the same quality of instrumentation, and never done from space. Even though space, you see, Eddington had to use a solar eclipse. Your eclipse has to be high in the sky, or you'll get too much aberration from the atmosphere, too much distortion. So it has to be a good eclipse, like the one we had in 2018 or whatever it was. Almost perfect over North America, and yet nobody with a good telescope did the experiment. And certainly didn't do it with photographic images or anything like that. So, never repeated. So this most famous experiment made Einstein a household word, never repeated successfully. And then the whole space argument is that if you use a telescope in space, you don't have to wait for an eclipse. You can do the experiment every single day. And you need a much smaller telescope. Eddington used a 12-inch. You probably only need like a 5-inch lens or something. There's probably a ton of satellites that have cameras that big on, with lenses on satellites. They've never, as far as I know, there's no evidence that anybody's even tried the experiment from space. It just doesn't make any sense. It's supposed to be, this is fundamental science. This is a fundamental contention of science, and yet they don't feel any need to really prove it. They just like to assert it. I'm not suggesting conspiracy of intent. I'm just suggesting a conspiracy of neglect. Science really, the physicists really don't care about the truth. They just care about their silly stories of woo, and this provides all kinds of ways to woo the universe. Gravitational lensing just allows them to do gravitational waves, and allows them to create all kinds of silly theory and create all kinds of speculations about all kinds of dark matter and all kinds of other silly crap. So that would be the extent of my conspiracy argument, is that most scientists are silly nerds who are dreaming about Star Wars adventures and are not grounded in any kind of understanding of their responsibility to get it right. Not to get it wrong, to get it right. They just don't care, frankly. Anyway, and nobody puts them on the frying pan, so to speak. They're not tested. They're not. They cloistered themselves away from any kind of commentary by calling everybody else a crank who disagrees with them, and they're just too pussy to man up and defend their rubbish. So these are images. So time moves on. We get better telescopes. We get the Hubble images, and we see things in space that look weird and strange and unusual. And they seem like, a little tiny bit, they seem like what we would suggest would happen if there was gravity and light had to pass through it, and it would be distorted in the sense that we would get an image from an apparent location, but not the real location, because we're seeing it through a kind of lens. So the argument about this is that gravity is exactly the opposite of a focusing lens. So focusing lens is, which I guess I should draw eventually, take light that's moving out, spreading, okay, and converges it back into a little point to make the image viewable. Now, when you travel a distance away from something, the light that you're going to start seeing won't be diverging light anymore. It's going to be more parallel. You're going to see the parallel rays. You're not going to see the diverging rays as much. The diverging rays are going to miss you as you get further away. You can sort of understand that the diverging rays are going to start missing. So you don't have to bend the light as much. At least that's the one advantage of collecting the more parallel rays. But you still have the same obligation. They're still diverging, and you still have to bend them to a focus, which means you have to make them go through a little tiny pupil eventually. Now, you could argue that the pupil of telescopes is the size of the lens, so you could argue that a 4-meter would be the biggest telescope lens I think we got. The Hubble is like some sort of 2 meters or something, and that's certainly very big when it's up in space. But that's a very small location. You're still bending the light to a very small location. Not the Earth, not the solar system. You're not bending it to a big giant lens. You're bending it to a very small location. And all the light, all the photons have to be consistently bent. That means each little photon that's coming from a different location in some galaxy somewhere has to be bent exactly the same amount for you to get an image. And if it's not, you're not going to get a good image. And so that's why lenses have to be very precisely made, and that's why the Hubble had a problem, is because the lens wasn't as perfect as it needed to be, and they had to compensate for its imperfections because it's really hard to do. But that's a side subject. Let's accept the existence of the images. Now, the obvious thing you can see in all of these images, every single one that's a real image, which is another thing to point out. Even Google's doing it, which is funny. They separate images into categories, which is really irritating. Just because, in most cases, it's just a way of again, Google telling us what's important in the world. But they actually have a category for gravitational lensing called real. That's right, because there's just so many fake images, synthetic images. And so it is kind of funny. I didn't click on that category because, well, I wanted to see some of these drawings and stuff just to point out how their illustrations are garbage. There's no one doing any precise mathematics on any of these objects to explain how this gravity could be where it is and how it could be as strong as it is in these locations. How the consequence of the gravity being strong enough to bend light this much is that there would have to be an intense amount of gravity, which means everything in the space around these objects would have to be shooting at very high velocities towards the centers that are creating this gravity. This is black hole style kind of gravities you're talking about. Big black holes, not little ones, big ones, to create enough bending for us to see these images in the first place. Now, the problem with gravity is the regular focusing lens bends light more on the outside than it bends it on the inside. Kind of obviously, the light's spreading, it's converging the light back. So that's the typical pattern they show. But gravity is exactly the opposite. Gravity bends light more, okay, on the inside. Gravity's strong, close to the sun, weak, far away from the sun. So it's doing exactly the opposite. That's never been explained, how a lens that's exactly the opposite of a focusing lens, that is a lens that collects a lot of light and then focuses it, right? That's the idea. You're collecting light over a large area and then focusing it, so you're making it much brighter, much bigger, because you've taken light from a big area, collected lots of photons. The idea isn't to collect a little tiny amount of photons and make them spread over a big area, and say, oh, I can see so much better. You can't see anything that way. You need more photons, not less photons, and gravity doesn't do photon collection well at all. It's a terrible lens for that purpose, and the only theoretical possibility is this thing called an Einstein ring, which is a tiny, tiny sliver of area that might send photons at the right angle to get a focus. but it would be a line so thin and so tiny, it would only be this much space in the galaxy, or this much space in the entire galaxy. So you can imagine only this much proportional photons would be represented in this image. So mathematically, it can't possibly work, because the line would be such a thin line, we would never be able to see it because there's too few photons being bent at the right amount. And gravity has an inverse square rule, which means the lens is sort of shaped almost like a diamond. It's it's a horrible lens in the sense that it's got so much distortion in it because gravity drops off at such a high rate. So any changes in distance would be changes that would destroy the image. Lenses have to be ground to a specific form to create the magnification necessary for the position they're in. It has to be a very exact thing. And gravity is not a good lens shape. And again, it's doing exactly the opposite. It's bending the light closer more and bending the light further away less. So you're still using light that's diverging, not perfectly parallel, and certainly not converging, which it would need to be doing. So if it was converging, then the object you're looking at would have to be much, much bigger than the object lensing. None of the images are like that. We're usually looking at a galaxy through the lensing created by a cluster of galaxies. I can point out that a cluster of galaxies, frankly, at the location these rings are at, the gravity would be insanely weak. The distance is so great and the density of the matter is so undense. There's so few objects. It's like taking the Earth and spreading it over the size of the sun as little chunks and then saying, I have intense gravity. When you know, no, you still only have the mass of the Earth, and now you have it at a diameter that's huge. And so it would end up being the Earth's gravity at, say, the distance of the moon. The Earth's gravity at the distance of the moon is minuscule, 0.0004 meters per second. I mean, insanely weak Earth gravity that you could feel when you were on the moon. You can't stand on the moon and say, oh, there's the Earth and it's pulling me. Not even close. You won't even notice it's there. It's such a weak force. Clearly not a force that's going to bend light. So there's no theory here that makes any sense at all. They don't really show any analysis of a single one of these images, any in-depth analysis of how this is even theoretically possible. You can clearly see on some of the images that it's giant clumps or stuff you're seeing with details in them. You wouldn't be able to get any of that by Einstein's theory of Einstein's rings. It's a tiny sliver, that's all you'd get. You wouldn't be able to get any depth or width of an object. These galaxies are light years across, they're huge. There's just no way you would see that much thickness of an object because every single photon throughout that entire thickness. So just think about it. Every single photon in that entire thickness has to be bent just the same. So you have to take that whole giant hunk of light and you have to bend it all exactly the same amount, proportional to its closeness to the center of the gravity. And there's just no theory that says that's possible. Then you could, I can make, these are just simple arguments, but the more mass you get, the more intense your spherical symmetry becomes, the more perfect it gets. So, and that's really just overcoming external noise. So even little water droplets have intense, perfect circularity when they're in free space. But big objects, it's just there's an insane tendency to become perfectly spherical because the forces that are holding the matter together are so much weaker than the force of the gravity. So any imperfections, any irregularities would be wiped out just because the crushing force is so intense that it'll just crush any irregularity out of anything, any imperfections. So gravity will always be mathematically perfectly spherical when it's at these kind of intensities, these black hole intensities. The spherical perfectness will be guaranteed. None of these images have any of any evidence of that. They're all way off in terms of they're not obeying the geometry. They're not perfectly spherical. They're not perfect in any way whatsoever. So I would argue what they really look like is the remnants from explosions. When black holes explode, sometimes they leave a ring of material that's been pushed out by the supernova. Sorry, when suns explode. So this is something we observe because it happens now and then in the universe. Blah blah blah. And all this is really saying is that there's times when something happens inside of galaxies and the galaxy explodes. And this would be what you'd see as a remnant, is there's a bunch of gas and material and suns and stuff moving away from a center where there was an explosion of some kind. And we're just seeing the remnants of that now. Those get irregular because there's different densities of the mass. The arms of the galaxy have different densities. So it makes sense that that stuff would end up being unspherical, imperfect, clumpy, lumpy, bumpy. And clearly the images are clumpy, lumpy, bumpy, inconsistent, indicating something moving, not something that's just a an image artifact, especially an image of something else that's been distorted. A galactic lensed image shouldn't be distorted because, as I'm pointing out, it's perfect symmetry. The lens is perfect. In terms of its shape. Again, I'll argue that the problem is it has the wrong, I don't know how to put it. I mean, obviously it's the wrong shape. I'm just saying whatever shape it would be a perfect bow tie. It would be a perfect of that shape. Now it's the wrong shape to do lensing, to be focusing, collecting a lot of light and focusing it. It's not going to be a magnifying lens. It's going to be exactly the opposite. But whatever it's going to do in terms of creating an effect, my point would argue is that it will be perfectly symmetrical because of the demands of what high gravity creates perfect symmetry in whatever it affects. So all these images have very imperfect symmetry. They're very incomplete. There's huge gaps in the circle. There's no explanation for how that happens. What causes those gaps? Where did they come from? Because they really theoretically shouldn't be able to happen. So you have these little tiny shreds of stuff. They're not at the same arc. They're at different arcs. Like you have a piece that's lensing for this circle and a piece that's lensing this little circle. None of it's consistent. And you can also big, huge, swirly blobs in the ends of things, big lumps and clumps at one end. Just no consistency with how perfect it should be. Even these very, very distant objects, lumps at one end, not at the other sides. It's not a perfect circle. It's got, puckers and distortions in it. Again, more stuff where you actually see the stuff still swirling. There's still activity going on, very thick. I mean, this image almost is so obvious in the sense that you can see material coming off of one object and coming off of another object. This is material being affected by gravity. That's a gas being affected by gravity, not light being affected by gravity. Again, these arcs are way off, almost straight lines here that don't make any sense at all. It wouldn't fit with the theory at all. Again, they keep drawing it as if it's a focusing lens, as if somehow the light on the outside is bent more and the light on the inside is bent less. Always drawn wrong. Focusing. Again, they just keep drawing it as if it's a focusing lens and ignoring the fact that an Einstein ring is going to be insanely thin. It's not going to be light years across. So again, none of it theoretically makes any sense at all, and the images just aren't nearly as perfect as, again, another silly drawing of, hey, here's more gravity way out here. There's not more gravity way out here on a galaxy. The outside of the galaxy has insanely weak gravity. It's like going to the outside of our solar system. Where do you think the gravity's stronger? In between the Earth and the Sun, are, right between the Earth and the Sun, are at the outside of the solar system. Yeah, the outside of the solar system, insanely weak gravity. So, like I said, it just doesn't make any sense. It's theoretically silly almost. Well, it is silly in my opinion. Some of these images are just so preposterous, all this swirling stuff, that it's not what gravity is going to do. This little stupid smiley face one is just so cute, but again, none of this geometry fits. The lines aren't symmetrical. There's no evidence that there's any real sphere here at all. Gravity has to be spherical. If there was as much gravity as necessary to bend all this thickness of light, then the intensity of the gravity here would be so strong we'd actually see the objects blue shifted as they were moving very, very fast, crashing into the smiley face. So, it's just junky science. These are all synthesized images of the black holes, all fake. The only real images they have are crappy. This is a fake image here. Swirling galaxies. There's no theory that makes that possible to see something light years across. Again, an Einstein ring would be a tiny sliver where the gravity would be just right to bend the light. And as soon as you went a little bit this way, too much bending. You went a little bit this way, too little bending. You're not going to see thick objects with gravitational lensing. Not possible. Theoretically, there's just no reasonable science. Einstein crosses and stuff, again, the same problem. There's no symmetry here. This is supposed to be intense gravity, so intense that it's, lensing a complete object, all of this stuff, and yet there's no symmetry. No perfect symmetry, which there really has to be. So, example of gravitational lensing. It says it right here. No, it's a completely synthesized image. It's not a real image. It's just fake. So it's just part of the propaganda to make this into some kind of real theory, when it doesn't make any sense at all. Gravity does the superposition thing. It all adds up, and it adds up to like the field lines around charges. They get very smooth as you go further and further out. This is just theoretically violates the grammar school versions of basic physics. It violates the fundamental laws as even theory. And the fact that none of these people who went to college have the integrity to point out how this theory sucks and stinks and smells and doesn't make any sense at all is, kind of disgraceful. So let's just hit the real button for the hell of it. Let's see what we get. So at least we have all these. It's just redundancies, unfortunately. They only have like 20 of these images that are any good. And, like again, this one is so preposterous in the sense that the symmetry is so bad and the objects are so inconsistent with each other from one side to the other. There's all kinds of artifacts and noise in the image. It just can't possibly be lensing. Those have to be objects. Those aren't optical distortions. Those are objects being affected by gravity. They're matter being affected by gravity. So let's point out just some more background. There's no evidence of any other force in existence, even photons. Can't make a photon hit a photon. Can't make a photon hit a magneton. Can't make a photon, you would argue, hit a graviton. There's no evidence that any of these forces, the stuff moving the speed of light, ever interacts with a force, that forces ever interact with each other, that they bang off of each other, they do any of that stuff. Forces only affect matter. They bang into matter, matter moves, and the force is readmitted. But there's no evidence that the matter absorbs the force in terms of absorbs the momentum. But there's no evidence that you can ever make a force manipulate a force. You can't make magnetism change gravity or any of that kind of stuff. You can only do the superposition thing, is which you can have a plus force this way and a minus force this way, and they won't interact with each other. But if you put a piece of matter in there, it's going to interact with the plus and it's going to interact with the minus individually as forces, so it won't mix ahead of time. Okay, the two objects won't feel force effects, and so it just doesn't happen. So we have no evidence that light can even bend light. You can't shoot light at light and make light bend. And yet what's the theory? Why is gravity special when it comes to light? Why can it bend light but it can't bend magnetism, and it can't bend gravity? Gravity can't bend gravity. At least we have no evidence that it can. So it just breaks continuity in terms of it establishes something alien and unusual and strange and kind of an extraordinary claim that there's this one special little circumstance where this thing called a photon gets affected, a force gets affected by a force, and that it somehow gets affected at twice the normal rate. That should require extraordinary evidence. Kind of an extraordinary claim should require extraordinary evidence, and this is far less than ordinary evidence. The evidence is terrible. The descriptions are just plainly wrong. They make no mathematical sense that there's more gravity out here than there is gravity in here. The light you have to bend, the wider you go, the more the light has diverged. So understand, the further out around an object you go, the more the light has to bend, because you're less parallel when the rays are starting. So obviously, if I wanted to lens something, I would never put if I wanted to have a hope of seeing some kind of lensing effect, I wouldn't put a galaxy this way and try to go out here and around the galaxy. I'd put a galaxy this way, and then I could go much more parallel with the light over the most intense part of the most gravitationally strong part of the galaxy, which is the thickest part, which is that center where the black holes are supposed to be. I'd want to send the light right close to those black holes, so I'd want to go around the top to bottom of the pancake. I wouldn't want to go around the outside of the pancake. The outside gravity is incredibly weak. Gravity here is incredibly strong. So I'd be bending more parallel light, which means I have to bend it less to make it focus. Huge advantage. Not a single image of a galaxy this way. Not a single image showing us how, where you'd rationally expect gravity to be the strongest. That's not what we see the effect being an effect. And again, this idea that a cluster of galaxies would have a huge amount of gravity is nonsense. The more spread out the matter is, the more empty space between the matter bits, the less gravity that thing as a whole can create. So density is incredibly important. That's why black holes have such intense gravity, is because the matter is dense. There's more of it per square inch of space. That's the whole point of the singularity and all that nonsense, is taking the matter and compressing it into a smaller and smaller location. A cluster is doing exactly the opposite. There's no huge gravity in a gravity cluster. A cluster of galaxies. It just makes no sense. And again, the more space, the bigger you make the lens, the more you have to bend the light to get it into a pupil. So it just doesn't make any sense at all. It's just garbage. As a science, as a theory, they just keep selling it, promoting it, and again, I don't see any of the rigorous math being applied here. I don't see any of the rigorous logic, nothing. Again, all these images, all this bending when the gravity bends exactly the opposite. Less bending out here, more bending in the middle. Doesn't make any sense. The lens is exactly the opposite for how they're drawing it. And the only way that drawing can make any sense is for one sliver, one tiny vector that would be correct and create an Einstein ring. And even by Einstein's own theory, the ring would be so thin, so few photons that you'd never see it. His prediction, you'd never see an Einstein ring, because there would be too little of it. And yet they're showing us images of Einstein rings that are hundreds of light years across. They're so huge. The other thing to remember, when two things move apart from each other, they don't get smaller. That's an optical illusion. Okay, that's what we see. Okay, but it doesn't really happen. Okay, when the two objects move away from each other, this hand didn't get smaller, this hand didn't get smaller. Hands are the same damn size. Okay, all that changes is the vectors of the photons that you will receive from each other, because the further away you go, the fewer of them are going to hit you from each other, because more and more of them keep going over this way, the angles. So the further and further away you get, the number of photons that'll miss you, that angle gets bigger and bigger, and this angle gets smaller and smaller. But that's just again an optical thing. It doesn't have anything to do with reality. So you always have to remember that things really don't get smaller. Okay, what else? Yeah, there's just a ton of reason to be very skeptical of what they claim. These are supposed to be real images. This is obviously a fake image. It's just so bad, ugly, messy. Again, they take these little tiny smudges, and they're saying, "Oh, that's proof of lensing." Yet again, all the circles created by these arcs are the wrong. They're not symmetrical at all. One circle will be over here, one circle will be out here, they're not at all consistent, and the gravity would have to be. There's just no way to avoid it. Big gravity is big spherical. You can't. It has to go spherical. There's no rational way to create uneven big gravity without the consequence of the gravity being so strong that all the matter will collapse very, very quickly. Alright, and there's just no evidence. Again, there's no images where they've taken the same lensing image 40 years ago, 10 years ago, 20 years ago, and they should have very interesting photographs of these things from different times, because they'd be from different angles. So understand that this satellite, if you're taking it from the Hubble, it's going to be moving to different positions in space based on the travels of the Earth around the Sun. So that's a very big pupil, in the sense that you're changing the angle, and you really should have very different lensing images. Frankly, the image should just go away, and we don't see any image of where smiley face isn't there anymore. So there should be an image like that, because you're receiving the photons from very different locations. In terms of you've moved your little tiny pupil, millions of miles away from each other, and the angle is so exact that it should make the image disappear. Yet we have no evidence that happens. Nothing. So this is just, it's way under analyzed science, where there's no real hard description of how this makes any mathematical sense. None of these questions are ever answered as far as I can see. The lens is the wrong shape. The lens can't possibly, because the gravity isn't the right shape. Even if gravity was not inverted, stronger in the middle, weaker on the outside, even if it didn't have that problem, it's got this problem where it drops off too quickly. And so the photons, you'd never be able to collect enough photons in the proportional bending. The bending would never be proportional. Then it wouldn't be the proper focus. It's just a fact. Alright, so I think I've made the argument. And so maybe I draw a couple of things, but I think you should be able to understand basically what I said without the drawing, but we'll throw it in for the hell of it. Yeah, maybe I'll think of some other point to raise, but it's sort of been said. Alright, should be back. Alright, so let's just do some of the basic idea that a galaxy doesn't change its size. So distance isn't going to change the size of something. So when they have a cluster of galaxies here, they're claiming that this cluster, for the obvious, what I would say is a dopey reason, right? This cluster has tons of empty space, all of this empty space in here. So you can understand its density is terrible in terms of the proportion of matter to space. Space dilutes gravity. So the more space something has in it, the more not electrons and protons. Electrons and protons create gravity. The more absence you have of those and the more empty space you have proportionally, the less the gravity. And so the galaxy is made of a bunch of suns and stuff, and so it's already, as a single object, it would have weak gravity anyway. But now we're just talking about the light. So proportionally, this is the ratio. And it doesn't change. It doesn't matter how far away I move this object. I'm not going to change the fact that this thing is huge, and I'm going to go to a little focus over here, a little tiny pupil. So this is always your problem, is that you're taking light that isn't going straight. You're not getting the parallel rays, the almost parallel even, almost, these are almost parallel. You're not just bending that little tiny bit to get to the focus. You're bending this huge angle here to get to the focus. And yes, the further away you move this, the more parallel these rays get, but you're still required, to bend a lot. And the further away you go, the more distance you create, and the more parallel you make these lines, the fewer and fewer photons you have, and each photon has to be bent. So if any thickness is there, each photon has to be bent exactly the right amount. That is, a little tiny bit more than that one, a little tiny bit more than that one, a little tiny bit more than that one. And as pointed out, the lens is the wrong shape for that. This is going to bend it less here, and it's going to bend it less here. So it needs to bend it more, and it's going to be bending it less. Obviously, these photons are not going to make it to this focus. So it makes no sense that you could have a big image spread over, the size of a galaxy here and have the right amount of bending. The bending would have to get stronger for these images, more bending on this stuff on the outside to get to this pupil. So there's just no way this could ever happen. You couldn't have a thick object here in this lens. You couldn't have the light from this object, come in here proportional to the shape of the object and create another image of that object here that you're going to now focus. It just can't happen that way. There's no physics that makes that make any sense at all. So yeah, not sensible. Alright, so the other point to make is, again, the Eddington kind of argument is that the problem with this, looking at the sun from the Earth, is the atmosphere, ends up scattering all the light that comes in. And so it's not really too good for viewing anything, because it's getting, the sun scatters, and so you can't do any viewing during the day. And you certainly can't ever look at anything around the sun because of the amount of distortion, because of the amount of light the sun is producing. So there's no black space next to the sun. And the point is if you get outside the atmosphere, then all these locations, it's perfectly black out here. Alright, so right next to the sun is perfect blackness, perfect blackness, perfect black. So you can see every little star behind the sun. You can see every little detail. And so none of that's been done. They haven't used a satellite and do a gravitational lensing with our own sun, the Eddington experiment. They've never done it from space, ever. Hasn't been done. With an optical telescope viewing the movement, the fact that the light from this object will be slightly bent, and we'll see it here, instead of in its true location here. Never been done. And again, this is a tiny angle, and the only reason why this was even a theoretically possible experiment, that is, the only reason why it was theoretically possible that the sun would have enough gravity to bend this light, is because Einstein 2x'd gravity. Said 2x the light, photons. Said they're somehow twice as affected as electrons and protons. So electrons and protons are only affected by 0.5 gravity compared to the photon. Photon is, no, 0.25 gravity, right? Twice as much, no, 0.5, yeah. So, I mean, it's does it make sense to you? It makes sense to you that photons are some sort of special case based on this tiny shred of tiny bit of evidence? You're sure that this is a truth? Because that's what Eddington found, was this 2x. He didn't find the regular gravitational amount of bending. He found the 2x version of the bending, the Einstein version. So then again, the experiment never repeated. And just so fundamental to their whole physics theory now. And it's just horribly under evidenced. And again, there's just no theory for how this could possibly happen. So just to, again, recognize the trick with the Einstein ring is there's gravity falls off at the inverse square rate. So it gets much weaker, half the distance. It's like this hand moving, right? Okay, the hand is 4 times bigger here than it is here. Just all I have to do is halve the distance and I have 4 times smaller hand. So it drops off really fast and gets, and so this, you need to bend light from each one of these locations. Again, you need to bend it more to focus. To create a focusing lens, you need to bend the light more the further away you go, not less. So you're not even bending it in the right direction, let alone proportionally, exactly proportional, exactly the right amount of bending. The inverse square law isn't going to do that. It's not the right shape of lens. It's first the wrong shape, and then it's bending more in the middle than it is on the outside, and then it's the wrong shape in the sense that the way gravity falls off is such a harsh lens that it can't possibly take photons from the same location and bend them proportionally the right amount. And the only thing you have a hope of is one single location, one distance from the gravity. So one distance from the gravity, you could have that the photons that are all at that distance going around the object would all end up being focused to some point, and they'd all get the same amount of bending, and so you could get that one tiny little shred of an image. But it'd be a tiny shred. As Einstein predicted, you wouldn't even be able to see it because it's so few photons. So it should be irrelevant to the conversation in a sense. By their own the hard mathematics says this is theoretical garbage, and they don't take any account for the fact that their own rigorous mathematics says it can't work. It can't be that way. So again, just do the light clock thing just to point out that this is where it starts. This is with a rocket ship moving very fast this way, maybe half the speed of light. And you shoot a laser beam across, and you're trying to hit a target here on the other side of the rocket ship. Well, you can understand that as the light's progressing, it takes time to progress. And as it's progressing, the ship is moving away, so this wall is moving away from the light, so it will appear that the light hits this location on the ship. So it would appear like it went down, when in fact the whole ship moved out of the light's thing, but the light actually went perfectly straight. It's just the perfect straightness. The wall of the ship moved out of the perfect straightness. So the light did go perfectly straight. It did do what it's supposed to do, which is go in a straight line, and the ship merely changed the target. It just slid a new target in front of the perfectly straight line. And as long as we're riding with the moving target, we'll see it hit the wrong target. But again, that's just what we're seeing. It's not what really happened. No photons bent down. It didn't happen. And so to make that the same as us getting pushed down in gravity on Earth, that's where all this comes from. So the force is pushing us down, which should be the same as the walls going up. Us being pushed down should be the same as the walls being pushed up. So therefore he had to make gravity do the same thing, which is fall down into the Earth. He had to make gravity push photons into the Earth. So the elevator here on Earth, going half the speed of light, going down, would be the same. And there was no reason to do this. This was stupid. There was no reason for Einstein to open that door, to even play with that idea. It doesn't go, it's not necessary. It's not a law of the universe. Again, the law of the universe is that clocks break. But the trick is, it's not a law. Because the catch is, the photon clock doesn't break. The magnetic field clock won't break. Clocks moving the speed of light, that have elements moving the speed of light, will not break. But you can't break those clocks. Force clocks don't break. Matter clocks break. Matter has to be moved by force. And gravity is a force. And acceleration, in the form of something hitting you that has momentum, or you using a big giant flame, to acquire momentum, those things all are forces. And those forces will cause you to move. That's what happens to matter. All right, matter can be broken. The condition of its metabolism, that is how the objects inside of it process when you have velocity. If I have something inside of me that does have spin, well, anything inside of me that has spin is going to be processing if I'm moving this way. And that procession means that each one of these loops takes longer because there's more distance in the loops now. They're longer than they are. They've been oblonged. Okay, they were circles, and now they're oblongonoids when they're doing this thing. Oblongonoids. Yeah, they're oblongonoids. So anyway, it's just I will in future tie this video up a little more sharply and tightly and write some stuff. I just haven't written on the subject of lensing because, frankly, it's not critical to my theory, really. I mean, obviously I would argue that these force laws are fundamental. Forces can't affect a force. Photons are a force. Anything moving the speed of light cannot bang into something else moving the speed of light, theoretically, in any way that could be significant. And I'll try to illustrate that too, in the sense that this is just basically a kinetic argument, that this stuff really is perfect kinetics, in the sense that you have two things moving into each other. The theory would be, if it took no time for them to interact, you can't really tell whether they go through each other. Okay, because what's your outcome going to be? Your outcome's going to be something going this way and something going this way. Now, if they hit each other and bounce away, well, that's exactly what that looks like. If they miss each other, this is exactly what it would look like. If they go through each other, this is exactly what it would look like. So it'll always look the same as if they miss. So force interacting with itself would just be the same as force not interacting with itself. It can't change the universe because there's a momentum in one direction, there's a momentum in the other direction, and that's what that's going to equal a momentum in this direction and a momentum in this direction. That's the conservation law. You can't evade the fact that that's got to all equal the same thing. You can't escape it. And the only way we escape it is that thermodynamically we're moving so slowly. We're moving in a universe moving much slower. And there can be little places where you have temporary, what appears to be changes. But in the big picture, there's no thermodynamic change. So in the big universe, there's no change. You can just change it in the sense you can have places in the universe where you have more stuff going this way. But there'll be another place in the universe where there's more stuff going that way. So it'll always equal. If you're looking over here, you'll see more stuff going this way. If you look over here, you'll see more stuff going that way. So just like time and flipping heads and tails. If you take heads and tails and you just flip coins, it'll come up, heads, tails, tails. Yeah, you could look at this part and say, oh, there's more heads than tails, or there's more heads than tails, looking in one location. But if you look at the whole thing, there are always going to be the same number of tails as there are heads, and it's always going to equal out. So anyway, I don't know if that's something that need to be added. So anyway, enough of the video. Again, it's not a subject I'm highly invested in terms of my own theory, because it's just not terribly important. I don't think it would fit. Obviously, I'm saying, why would there be an exception for photons? But if that's what happens, if that's the way it is, well, okay, that's the way it is. I don't have an explanation for why there's a difference, just as they don't have an explanation for why there's a difference. It's just the rule. Okay, fine. But yeah, it makes no sense. It would make the theory ugly. Okay, it would create a stupid question to have to answer. So I don't believe it's true. And my theory doesn't predict it, certainly. And finds it, I guess the point would be, is my theory tends to argue, no, that really just makes it not work as well. So it just breaks something that doesn't need to be broken. In terms of a principle, that force doesn't interact with force in any way we could detect, any way that could matter in the universe. The interaction creates no change in the universe. That's the big key word, I suppose. Any interaction between a force and a force can't create change. In terms of momentum moving in a direction, whatever goes in will come out in direction. There's no mechanism for a force to be able to change the vector. And the only way you can change the vector, the angular momentum, the momentum at a vector, the only way you can change that is you have to hit a piece of matter that has a whole bunch of angular momentum and a whole bunch of stuff, and it can release something different than what went in. And that's when you can change the universe. It's when a force interacts with an electron, or a force interacts with a proton. Then the universe changes. Alright, yeah. So I think that covers enough on this subject. Again, I'll just point out that what this illustrates, it isn't a defense of my theory to point out this criticism. It's a defense of my accusation that physics isn't being done with any kind of integrity or scrutiny or high precision. That if they can believe this is real and it's not, they're believing all kinds of other stuff that's real that's not. That you can't just take their word for it. They're not a trustworthy source of facts. For them to argue that it's a fact that light is bent by gravity based on this horrible evidence. I mean, the evidence is horrible. It's so weak and imprecise and unclear, and it's fraught with all kinds of difficulties for which they don't explain. Why don't we see more lensing? We know there's places in the universe that have intense gravity. We're watching objects falling into it. Big objects are falling into it, and yet there's no lensing in those locations. Why isn't it there if it's real? They have no they have no answers for all these critiques. This is horrible evidence all the way back to the Eddington experiment. Again, never repeated, not even done on the 100th anniversary of Einstein's paper. Right, it's his 2019 is when was the big year in terms of his validation, but 2015 was his paper, and here we had this perfect eclipse in 2018 and nothing. 2017, well, whatever. Nobody does the experiment with any kind of precision. The perfect eclipse over the most technologically advanced country in the world, over a big giant part of that country, hundreds of miles, 1,000 miles maybe, of the country affected by the eclipse, perfectly overhead, happened at 12 noon, in the middle of the country, and nobody did the experiment. And the fact that we have thousands of satellites, no doubt, that have decent telescopic lenses on their cameras in space right now, and nobody attempts the experiment. How do you explain that? Alright, so I've done my job. Again, all I can ask is for you to be reasonable, and it's reasonable to doubt these lawyers, these advocates, saying, this is truth, this is evidence, this is really solid, we've proven it. There's real reason to doubt these people. These people are Johnny Cochranes, okay? These people are shysters of physics because they just don't care about having real evidence before they claim a truth. They say, we've done it, when it's really murky whether they've done anything at all except waste a big pile of money. We found the Higgs boson. Yeah, and the evidence is mush. Okay, it's such an indirect. We found a person who saw the photograph of the guy who took the photograph of Bigfoot. It's so distant from anything hard and solid. It's the eyewitness testimony is so distant from anything you can depend on. This is barely hearsay evidence, and yet they're talking as if they've got solid, rock solid proof. And if you find that trustworthy and reason to think they have integrity, I'm saying you're just plainly unreasonable. You're a fanatic then. If you can't concede that they've jumped the evidence way ahead of the evidence, and that they haven't dotted all their I's and done the proper thing they're supposed to do before they make declarations to all of us that we can start with these axioms. Light is bent by gravity, and this and we can establish these that are fundamental, foundational truths. And that's what they're saying. They're calling you a flat earth asshole or a jerk or a crank if you dare to impugn the integrity of this nonsense. We have to believe time is a dimension. We have to believe what's the other crap? The wave particle duality. We have to believe in dark matter. We have to believe in all this crap. And the evidence is obviously not what it should be. And you people who can't concede that and can't concede that is reason to doubt any extraordinary claim they make is doubtable, because clearly we have evidence that they'll always stretch the evidence. They'll take a grain of truth and turn it into a beach of synthetic fakery. They'll start validating their theory with fake images, essentially. Well, look at that. How can you deny that image? Look at that. That's a perfect Einstein ring. Blah, 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 blah. It never happened in reality. So anyway. Like I said, all I can do is make the reasonable argument that there's reason to doubt the story they're telling you. And yeah, the only way you can really know is you have to do all this research yourself and figure out all these truths about how this stuff works, because they're not going to show you their underperformance. They're not going to show you when the math doesn't work and when it doesn't make any sense. You have to know enough to figure it out. And that's what makes this all so freaking insidious, that none of these people have the integrity to stand up and say this is bullshit. Just like none of the cops have the guts to stand up and say, yeah, we're fucking robbing you blind. Preposterous overtime. We're eating sandwiches and donuts, getting $250 an hour, watching a parade. I mean, just horse shit we're getting away with. And besides all the criminals we're stealing crap from and all the other graft, and none of them have the guts to stop it. And there's all kinds of graft going on in this thing called physics and such.